Okay, let's do another example. So this will be our final example. Okay, so the U.S. Department of Transportation, and let me actually erase this, right? You should know what this is, shouldn't be thinking about that. So the U.S. Department of Transportation reported that 75% of all fatally injured automobile drivers were intoxicated. A random sample of 32 records in Carson County, so we have 32, showed that 16 involved a drunk driver. Use a 99% confidence interval to determine whether or not there's evidence that indicates that the population proportion of driver fatalities related to alcohol is different than 75%. Okay, I think we can do that. So we know this is an interval because it says calculate a confidence interval. So let's go through our steps. Some can calculate intervals. So first we're going to look for our statistics. So before we start calculating statistics, before we start looking for statistics, we should ask ourselves, is this about a mean or about a proportion? So we're going to look through for hints. So do we see the word mean in here anywhere? We don't see anywhere them talking about mean or standard deviation, but here we do see the word proportion. So that should tip you off. We never got anything about mean or standard deviation, but we are talking about proportions. So that means we need to be looking for a p-hat and an n. So just so you know, sometimes they don't give you p-hat, but p-hat, which is the proportion, is just x divided by n. So as long as you have x and n, you'll also have p-hat. And then we also need our confidence level. Okay, so we know our confidence level is 99%. We know that our n, or our total sample, is 32. And then we don't have a p-hat, but we do know that x is 16. Pardon, so if we say 16 divided by 32, that will give us our p-hat. So 16 divided by 32 is 0.5. Probably could have figured that out. So our p-hat is 0.5. Perfect. So we have all the pieces we need. Okay, so we got our statistics. Now we're going to check our conditions. So remember, we're going for RIN. So the first in RIN is R. All right, we want to see if it's random. And they said right here that it's a random sample. So we can say random sample. So check, we have our random. Next, I. Is this independent? So again, we want to say, is the population size larger than 10 times the sample size? So I would say the whole population of, unfortunately, of records, of automobile accident records is greater than 320. So, yes, it is independent. So lastly, we need to check if it's normal. Now remember before we've been just saying, okay, is n greater than 30? But that's only for means. Now we have a proportion. So we have to be saying, is n times p-hat and n times 1 minus p-hat, are those both greater than 10? Okay? So n times p-hat, in this case, n times x over n, because that's how we found our p-hat, is just 16, right? So you can always calculate it out, just say 32 times 0.5, but if you did that, you'd find that it's just 16, right? So yes, that is greater than 10. And then n times 1 minus p is going to be, sorry, let me change where I'm writing this so I'm not running off the page. So n times 1 minus p-hat is 32 times 0.5, right, which is also 16. So yes, we have all our conditions checked. It's random, it's independent, and it's normally distributed. Perfect. So let's move on and actually calculate this, right? Some can calculate. So we have 16 and 32. Okay. So we know that x, our number of successes in this case, is 16. N is 32, which means that p hat is 16 over 32, which is 0.5, which means, oh, sorry, not which means, and then next, our confidence level was 99%, and our confidence level is 99%. Okay, so let's go through and calculate. So we want our point estimate plus or minus our margin of error, Okay, so in this case, our point estimate is going to be p hat, right? Because now we're dealing with proportions. And our margin of error is going to be z star, right? Because it's always z star when we deal with proportion, times our standard error. And remember that our standard error is p hat times 1 minus p hat over n. So now we can plug everything in. So we have 0.5 plus or minus z star, okay, we'll get that in a second, times the square root of 0.5 times 1 minus 0.5, which is also 0.5, but let's write it out as 1 minus, so you see where it's coming from. 1 minus 0.5 over 32. Okay, so our final step is to calculate, or not our final step, but we also need to calculate our critical value. So we'll draw our little picture. Okay, so it's 99% in here, which means we have 1% left over. We divide it in half, so it's 0.05%, or we just put in inverse norm, 1 minus 0.99 divided in half. So we don't have to worry about any degrees of freedom because we're dealing with a z. So let's look that up. Okay, so second vars, inverse norm, 1 minus 0.99 divided by 2 gives us, and remember we're always using absolute value, so 2.58. Okay, so our critical value is 2.58. And now we're just going to do the math. Okay, so move this over. Okay, so we'll start with our standard error. We know that it's 0.5 times 1 minus 0.5, which is just 0.5. Okay, divided by 32. And I always do in my calculator from inside out, because that way I don't have to put all the parentheses. I'm just kind of moving out. Okay, and then square root of that value. Perfect. So my standard error is 0.0883. So this is and then these are still the same. Okay, so it's going to be 0.5 plus or minus that value times 2.58. 2.58. So my margin of error is 0.228. Okay, so that means that my confidence interval is 0.5 minus that value. So my lower bound of my confidence interval is 0.272. And my upper value is 0.5 plus this 0.2880419. It's good to put lots of decimals because the more decimals you put in your calculation, the more precise your actual answer is. Okay, so it's 0.788. Perfect. So now before we go on to our next step, we're going to check our work in the calculator. Okay, so in order to get to our confidence intervals, we're going to go stat over to test, and then we're going to go down to the intervals until we get to our 1 prop z int. So it's 1 proportion z interval. Okay, x. Well, our x is 16. Our n is 32. and we're doing a 99% confidence interval. So just a quick note, if you hadn't been given x and n, you'd been given p hat and n, you could have solved for x, okay? So you can always get that. Okay, then we're going to calculate, and there we go. Move it over just one more time. Sorry for the back and forth. So we have 0.72 and 0.788. Okay, so it looks like maybe I'd done a little algebra, a little adding, subtracting wrong. So this is good. This is exactly why we want to check our answer in the calculator. So this should be 0.727. So, or rather 0.728. Okay, so I don't know what I added wrong here. Let's double check my math. That's why I'm checking in the calculator, right? So 0.5 plus 0.228. See if it was something simple like that. Yep, I just wrote it down wrong. So sorry if you've been going along saying, no, it wasn't supposed to be 0.788. It was supposed to be 0.728. But that's why we check on the calculator. Okay, perfect. So we've done that. We've calculated, right? Some can calculate, right? Statistics, conditions, calculations, and now intervals. We're going to interpret. Okay, so we are 95, oops, sorry, gotta check my answer, check my question. We are 99% confident. And here's where you want to go back to your original problem and see what are we even being confident about. Okay, so the population proportion of driver fatalities. So we are 99% confident that the true population proportion of driver fatalities and if we go back one more time, it's driver fatalities, and we took a random sample from this Carson County. So that's actually the only place we're going to be able to draw our conclusions about. So if you remember from developing surveys and doing experiments, you have to have a representative sample in order to draw conclusions about your population. So we're 99% confident the true population proportion of driver fatalities in Carson County is between 0.272 and 0.728. In other words, 27.2% and 72.8%. And now, remember they asked us to check, oops, sorry. They asked us to check if we thought that this indicated, if our data indicated the population proportion was different than the 75%. So let's go back to our interval. So again, our 75% is not in our interval. So we'd say 75% is not in our interval. So it appears that Carson County is lower than the U.S. Because remember, the 75% was for the whole U.S. And there you go. We have some can calculate intervals. We looked at our statistics, we checked our conditions, we calculated our interval, and now we interpreted. So we hope to see you again at Educator.com.